Dear students, in this lecture we will learn about regular falsi method or method of false position to solve f of x equal to 0. F of x is a non-linear function which will be given to you people. So the steps which are going to be followed in regular falsi method, you will be given a function f of x along with interval a b, and if the interval is not given to you, if this interval a b is not given to you, then you will put x equal to 0, 1, 2, 3 and so on in the given function, and will note this change of sign in f of x, and we will note the sign the change of sign in f of x whenever we put x equal to 0, 1, 2 and so on. Third one, we need to find f of a and f of b as discussed in the previous methods, and the fourth one is we need to find c by a regular falsi method. Remember that c, the formula for c in bisection method, and the formula of c and secant method, and now the formula for c in regular falsi method. These three are different from each other. So the formula for c to obtain is a f of b minus b f of a divided by f of b minus f of a, but provided that f of a multiplied by f of b is negative. So this formula will be valid whenever f of a multiplied by f of b is negative. So we see that this c and the c and secant method, these two are same with each other, but this condition, this restriction is in regular falsi method, that f of a into f of b will be less than 0. The formula for c is the same, and then we need to find f of c. We need to find f of c, and note that whether f of c multiplied by f of a is negative. If this is negative, then the interval reduced to a comma c, and we will replace b, which is missing in these two. We will replace b by c. So whenever we replace b by c, then again we find c by the above formula and obtain f of c in that manner. But if f of b into f of c is negative, then the interval will reduce to cb, and we will replace, because a is missing here, so we will replace a by c and find c by the above formula and obtain f of c. And we will continue this iterative process to get the required accuracy. So let us start an example. Example is the question is, use the method of false position to find the root up to 4 decimal places between 0.4 and 0.6 of the equation sin x is equal to 5x minus 2. The solution is we are given a 0.4, given b 0.6, and f of x is shifting 5x minus 2 towards that side, so that will be sin x minus 5x plus 2. That is actually the function f of x. Now find f of a. F of a means f of 0.4, so f of 0.4 is equal to sin of 0.4 minus 5 into 0.4 plus 2, and this is equal to 0.3896. Again f of b. F of b is sin of b minus 5b plus 2. Sin of b means sin of 0.6 minus 5 into 0.6 plus 2, and this is negative. We see that f of a multiplied by f of b is negative, because the sign of these two are different. Plus into minus is minus, so the root will lie between this interval a and b. So we find c by a false position method by this formula. C is equal to a f of b minus b f of a divided by f of b minus f of a. That is the same formula which is used in bisection method. Now replacing a by 0.4, f of b by minus 0.4354, then b by 0.6, and f of a by this value to calculate this fraction, and this is 0.4944. This is the value of c. Now put this c and the given function, this function, replace x by c, and c is actually this 0.4944. so that is sine of 0.4944 minus 5 into 0.4944 plus 2, and this value is equal to 0.00238. that is f of c. Now just look at these signs. F of a is positive, f of b is negative, and f of c is positive. F of c is positive, so plus into minus is minus, so it means that f of b into f of c is less than 0. So root will lie in the interval cb, this interval. So this interval ab reduced to interval cb. The rest of the story is mentioned in the following table. This is the table. This is the number of iterations: a, b, f of a, f of b, and then c. Because for c we need a, b, f of a, and f of b, so that's why we have calculated f of a and f of b first and then c. That is the same story as repeated in the secant method. Now again, find f of c as discussed in secant method. So this is f of c. Now note that whether this is f of a, this is f of b, and this is f of c, we see that f of b and f of c have opposite signs. So f of b into f of c is less than 0, so we will replace a by c, which is missing in these two. A is missing here, so a will be replaced by c. So see here, this is the value of c, 0.4966. this will go there instead of a, 0.4944. b remains unchanged. This is f of a. Now with the help of calculator, as discussed previously, that how could you calculate these values, that is being discussed in the previous lecture. So a is replaced by c, this is c and this is b. Calculate f of a, f of b, and find c, and then calculate f of c, and see here that f of c and f of b have opposite signs. So f of b multiplied by f of c is negative, so a will be replaced by c. A is missing here, so a will be replaced by c. So again, this is the value of c. This c will be here instead of a here, and this is b. Now calculate f of a, then f of b, then c, and then f of c. So we see here these two consecutive values of c are nearly equal to each other up to 4 decimal places. So the required root is 0.495 and 0. So this is how we use regular falsy method to find the value, to find the root of nonlinear function.